the heat that is added is not increasing the temperature of the water, it's rather breaking intermolecular forces. And that is why it is called latent heat of fusion. Latent heat of fusion is the amount of heat required to change the state of an object from solid to liquid. So latent heat of fusion, latent means hidden heat. So the heat is hidden because it's not raising the temperature. Rather, it's breaking intermolecular force to change the state of the ice to water. What quantity of heat is needed to melt 120 gram of ice at minus 20 degrees to water at 30 degrees Celsius? So you are melting the ice at minus 20 degrees to water at 30 degrees Celsius. Now, if you want to look at the whole process that is taking from change of state of water from solid to liquid to gas, the graphs look something like this. So if this is our 0 degrees Celsius, this axis is temperature. So this is negative. It gets to 0 and go this way and go. Gets to 100. This is water, remember. At 100, it goes this way and then go up. Above 100 is steam. So it's ice here. This is ice plus water. This is water. This is water plus steam. This is steam. Now, what do we mean? Below 0 degrees Celsius, water is ice. It's in the solid state. When it moves from between this point to this point, specific capacity of ice is at work, raising the temperature. When it gets to 0, heat is added, but the heat that is added is not increasing the temperature of the water, it's rather breaking intermolecular forces. And that is why it is called latent heat of fusion. Latent heat of fusion is the amount of heat required to change the state of an object from solid to liquid. So latent heat of fusion, latent means hidden heat. So the heat is hidden because it's not raising the temperature. Rather, it's breaking intermolecular force to change the state of the ice to water. So after the quantity of heat, this is for quantity of heat now, or heat energy. You are still adding more heat energy, but it's still remaining as ice. Once it gets broken, finish. Once all the intermolecular forces that keep it as ice is broken and it becomes water, then specific heat capacity of water will start working. Here we have said specific heat capacity of ice was working. So the temperature will begin to increase and get to 100. Once it gets to 100, latent heat of fusion. Here is latent heat. This is latent heat of fusion. This is latent heat of vaporization. So the latent heat of fusion will begin to break the intermolecular force of the water. Break. Once it finishes breaking, temperature will begin to increase again. Water will now change to gas. Steam. This is the liquid state, and this is the gaseous state. So this is how water change from solid to gas. The quantity of heat required is the specific heat capacity that take it from ice to at negative to 0 degrees. The latent heat of fusion that break the 0 degrees to become water, liquid. Then the specific capacity of water that take it from 0 to 100. The latent heat of vaporization that breaks the intermolecular forces of water to become steam. Then the specific capacity that can take the steam from 100 to whatever temperature it's going. All right, back to the question. To melt an ice from -20 to water at 0, you need Q1, which is mass of the ice, then the specific capacity of the ice, times change in temperature, which is mass of the ice is 120 gram. 120 gram is 120 over 1000 kilogram, which is 0.12 kilogram. So here we are going to be answering our question in kilogram. The unit, the SI unit is in kilogram. So that's 0.12 times specific heat capacity of ice is given as 2100 joule per kilogram per Kelvin times change in temperature. Final temperature will be 0 minus initial temperature is -20. All right. So this gives us 0.12 times 2100 times 20. And that gives us what? 5040 joules. This is the first quantity of heat that is needed to increase the temperature of the ice from 0 degrees Celsius to 20, from -20 degrees Celsius to 0 degrees Celsius. So at 0 degrees Celsius, Q2 is the specific latent heat of fusion that will break the intermolecular force, which is ml ice, which is 0.12 times latent heat of fusion of ice is 3.36 times 10 raised to power 5, which is 0.12 times 336000, right? And that gives us what? 40320 joules. So this is the specific latent heat of fusion. This is the quantity of heat that will now be required to break it at 0 degrees Celsius. There's no change in temperature because the heat is breaking the intermolecular force. The third heat will now take it from that water at 0 degrees Celsius to water at 30 degrees Celsius, which is Q3, which is MC water times change in temperature, which is 0.12 times what specific latent heat of specific heat capacity of water 4200 times change in temperature will be 30 minus 0 because it's changing from 0 degree to 30 degrees. So that gives us 0.12 times 4200 times 30, and that is what? 15120 joules. So you need 5040 joules to take it from ice to water at 0. You need 40,320 joules to break the intermolecular force to make it water, to free it. Then you now need 15,120 joules to change the water from water to steam. So from water at 0 degrees to water at 30 degrees. So the total quantity of heat required is equal to Q1 plus Q2 plus Q3, which is 5040 plus 40320 plus 15120, which gives us what? 60,480 joules of heat is what will be required to melt ice, 120 gram of ice at -20 degrees to water at 30 degrees Celsius. Thank you. Make sure you like, share, subscribe, follow me, and let's do this again. Hasta la vista.